just a second. Let me just make a little room, shrink this down. Now let's talk about sig figs. Let's talk about sig figs. So our resultant equals 9.391 newtons at 3.38 degrees. Sorry, I put newtons as 3.38 degrees, not newtons. 9.391 newtons at 3.38 degrees. And 3.38 degrees, we started east and then we went north of east. So we went 3.38 degrees north, 3.38 degrees north of our original eastward direction. So that would be the answer. Or if you want to think about counterclockwise from our eastward direction, what you could do is think of it as, let's redraw it here. Okay. So what would this angle be if we started from horizontal and went all the way around? This would be 180 minus 3.38. Okay, 180 minus 3.38. But let's go back, and this would be the resultant. Oops, y'all give me one. Okay, I'm back. I got distracted there for a second. Okay, so our resultant was 9.391 newtons at 3.38 degrees north of east, and forget about the angle, because of course 3.38 degrees is already in the eastward direction. So this is counterclockwise from the eastward direction, 3.38, and it's also north of east. Okay, so that's two ways that you can describe that. Now, let's look at sig figs. Now, sig figs, go back and look at all the numbers in the original problem by just going back. In the original problem, we were given 14, 47, 334 and 11.2, 205 and 11.3. 11.3 and 205 are both 3 sig figs. 11.2 and 334 are both 3 sig figs. But 14 newtons and 47 are 2 sig figs. Alright, so our final answer has to be 2 sig figs. So let's go back. And we're going to convert this to 2 sig figs. So that's going to be 9.4. We're going to round that. And we can go ahead and round this to 3.4 degrees north of east. Now, that's not our answer. This is our total of all 3 angled vectors. Okay, that's the total of all 3 vectors added together. If you actually added them together on graph paper and then just measured from the first one to the last one, then you should also get this same answer approximately. But the question, if we go back, the original question, which makes it a little bit more challenging, is what is the equilibriant? What is the equilibriant? So in this problem, we had one that was going this way, one that was going this way, and one that was going this way. Okay? So what we want to do now with a final, if the total of all of these, okay, if the total of all these, you add them together, all 3 of these equals this, which was 3.38, which we rounded to 3.4, and the magnitude was 9.391, which we rounded to 9.4. If that's our total, if the total is that, then what would the equilibrium be? That means how much would the rope have to be pulled to balance it? It would be the opposite. Okay, so if this one is, this one's 9.391 newtons, the opposite would be 9.391 newtons. Okay, now this angle right here, different color. If this angle right here, whoops, okay, if this angle right here is 3.38 degrees, then this angle down here would be 180 plus 3.38. So let's think about complementary angles. Let me try to redraw it. We've got this one up here. Try to draw it a little bit neater. Which is 3.38. And then we're saying we're going to do the opposite, which is going down here. So that means that if you know a little geometry, if this one down here is 3.38, then this one over here has to be 3.38. Okay, complementary. So let me change pin code. So if we go from horizontal here all the way to here, would be 180 plus 3.38, which is 183.38. So our equilibriant, okay, our equilibriant, or if we want, we can call it our resultant equilibriant, is with sig figs going to be 9.4 newtons at 183 degrees counterclockwise from east. Okay, and that's our final answer. Let me just write that a little bit neater. So our equilibrium is 9.4 newtons at 180, and it was 3 point. The angle was originally, what was it again, 3.38, so we call that 3.4. So that's 183.4 degrees. And so for sig figs, we're going to call that 9.4 newtons at, and we're going to round that down to 180 degrees. Okay, that gives us 2 sig figs. Now, that's going to be counterclockwise from east. Another way that you can write that, because our equilibrium, if you remember, was down here, and you can make it a triangle that's like this, or you can make it a triangle that's like this, or you can just say counterclockwise, like this one. So if you want this bottom triangle, then it would be, the resultant equilibrium would be 9.4 newtons at 87 degrees west of south. West of south. Okay, so let's see. Let me double check that. Yes, so this was that would be this one right here. So let me rephrase that. That would be this one right here. So if we go back to our previous page. If this was 3.38, this is 3.38, okay, then this is going to be our 87 down here. 87 down here, or 3.38, or just round that to 3.4-ish up here. So 87 is going to actually be, it's in a southward direction. Okay, it starts in a southward direction and then it goes west of our south. That's 87.5. Now for this top one, the resultant equilibrium would be 9.4 newtons at, this one's 3.4, but it starts west and then it goes south of west. So we're going to reverse that, south of west. Okay, so here's our three possible ways of writing the equilibriant. Okay, so this one is counterclockwise from east. And this one in here at 87 degrees is if you drew the triangle like this, okay, with this angle, where it starts south and then goes west of south. And this one is if we drew it, this one over here is if we drew it like this, where it starts west and then it goes south of west, south of west. So these two triangles are complementary to each other. You can draw them either way, where the x and y components are on the top of the resultant or the x and y components are on the bottom. So you can do either of these. So I took the time with this problem to walk you from beginning to end and show you some of the details of the problem that we weren't able to go through in class. Some of the things I assume you know from trig, but I know a few of you may be a little rusty, so you can go back and look at Khan videos to get practice on that. I also have a link on my homepage of my D2L website that you can go back and do some trig practice. And feel free to look at this video, review it several times, and see what kind of questions you might have. And feel free to come in the morning and see if I can answer any questions for you. Okay? Again, this is a level 3 vector problem. It's very challenging, and my goal is for all of you to be able to master this problem. All right, the best of luck, and I'll see you soon.